does not overlap on any of the edges. It can visit vertices multiple times. So if a graph has that property, theoretically if you had a long enough balloon, you could make it. And so the graphs that have an Eulerian path, or an Eulerian cycle, I guess, is the easy even one where it completely loops around to the beginning, are the ones where it has an even number of vertices. So out of the Platonic solids, there's only one, that's the octahedron, that has all the number of vertices, have 4 edges coming into it. Here's another polyhedron. If you've got just 2 vertices that have an odd number, that can be like the beginning and the end of your balloon, and then you can also do it with one balloon. So that's one balloon, and that's one balloon, and that's the octahedron made out of one balloon. A cube, it's impossible to do with one balloon. In fact, it's got these 8 vertices that all have, they're all of degree 3, they're all odd. So how many balloons do you need? What is a balloon number? That's a technical term. And BLOON, that's our technical term for the theoretical version of a balloon. So the balloon number of the cube is 4, because for each odd vertex, it's going to have an end of a balloon at it. Other balloons can come in and out, and every time they go in and out, there's going to be 2 edges, one from the in, one from the out. So you can pile up even numbers all day having balloons go in and out. But when you have an odd number, that last one after all the evens, it gets stuck. It can't go out again, or else it would create an even number. And so each vertex has to have if it's an odd degree vertex, it has to have an end of a balloon. Each balloon has 2 ends. So if you take the number of odd vertices divided by 2, you get the balloon number, how many balloons you're going to need. So for the icosahedron, it's got these vertices of degree 5, and it's got 12 of them. Therefore, you need 6 balloons, and then you figure, all right, an icosahedron has 30 edges, so 30 divided by 6 means you're going to need 6 balloons, each twisted into 5 sections, and then now that's a good way to start designing a good icosahedron balloon method that's going to be optimal and computationally efficient, which is, of course, the goal. See, I think there's some icosahedron going on there. But you weren't computationally efficient. Yeah, we're having a problem where you're running out and you don't know where to. Well, there's going to be friction involved. They're balloons. So here's one solution. So there's 6 balloons, each divided into 5 sections, put together with nice symmetry. Yeah, here's some things and their balloon numbers. And then thinking about other graphs, like even infinite graphs. This is infinite, except, it should maybe, is that Eulerian when it's infinite, but all the vertices are of even degree? I don't know. It's like you can't make that out of just one infinitely long balloon, or can you? I don't know. So I cheated and I used multiple balloons and just made the parallel lines the same color. Yeah, figuring out how many segments to twist your balloon into. So for this infinite graph, I couldn't just count the number of edges there are and divide it out. I had to figure out what unit to use, and it ended up you twist your balloon to 7 sections, and that's optimal. Yeah, maybe we'll make one of those. I don't know. We could start with an octahedron. You've got skinny balloons at your table, and if you take that skinny balloon and a skinny pump, I'm going to borrow this. I'm going to inflate this balloon. All right, so when you're inflating a balloon, some of you probably already discovered you need to leave room at the end, or else you can't twist it that many times. And for an octahedron, it's got 12 edges. So you're going to have to leave a lot of room at the end for the air to kind of squish into. So, I don't know, you leave 4 inches or something at the end. Tying the balloon off is the hardest part. So you can blow out one of these. And then to twist these sections, I start by twisting off 5 sections. If you just twist your balloon, it'll probably unpop. So I err on the safe side and I make really small sections for an octahedron. And then if you bend it and hold it in your hand, You can compare length that way to get one that's the same length, and then bend back up and keep them all from untwisting. So that's a way to get first 5 sections twisted off if you're going to make an octahedron. If you got 5 sections and you twist the first to last to get it, that's going to be your cross section of an octahedron. Oh, do you guys not have enough light here now? Oh, okay. Yeah, if you're using the fat balloon, you're going to have a lot of trouble getting 12 sections out of that. You can see you're already like halfway across with 3 sections. So you either have to make really small sections, but I suggest starting with the skinny balloon. All right, if you have 5 sections, and if you don't, that's fine. Yeah, twist them around so that you get this square. The first connection to the last connection should give you a square, or else you don't have 5 sections. All right. I see we got a couple people with that. All right, we got some people with the square. If you twist 2 more sections off of the same length and connect the second one to the opposite side of your square, and you just can kind of snuggle it in, and it'll hold by friction. Yeah, 5 sections should make a square with a tail. Oh, yeah. It's not a section yet. It is the future. It should be a square with a tail. So you should twist off 5 sections and then do the first twist to the last twist. Yeah. All right, if you've got your thing. Yep, then 2 more sections to connect opposite. Okay, if you've got this, twist off just 1 more section that you're going to connect to the very beginning of your balloon, and you'll see this kind of symmetric 4-way thing. So just 1 more section will connect to the beginning of your balloon. And then you can probably guess what to do from there. So you're up to 2 more sections to connect to the opposite corner. So this second section will connect to the opposite. Yeah, so you're up to 2 more sections, and the second one will connect to the opposite corner. Yeah, that's good. That's good. Yeah, twist that.
Like this?
Yeah. Yeah, snuggle them in. They're tough. They can take squishing. All right, that's good. Yeah, you just have to snuggle them in. Just squish it.
At balloon school.
You're learning very swiftly. And then from here, can you tell what to do to get an octahedron?
Not at all equal. Wait, what am I missing? No, I fixed it. It just was inflated.
Oh, nice. All right, so do 2 more sections, and the second twist will connect to the opposite corner. Oh. And just kind of snuggle it into the opposite corner. Yeah. Yep. Good. All right, you're probably going to run out of space, but you can always do another. So the next step is to twist off 1 more section and connect it to the very beginning of your balloon. Yeah.
Yeah,
Oh, you ran out of room. That's why I recommend the skinny ones, because they...
So you got to think about 12 sections. No, how many sections do you got to think about?
12 sections, yeah.
Sections, yeah.
So that's why I start, and I err on the safe side. I really go for small sections. And if you got extra, it's okay.
Yeah.
Should you just make your sections and then it will form itself?
If you make all your sections first, yeah, they'll kind of pop apart. Oops. Nice octahedron. Beautiful.
Go like this.
Oop. That was me. Okay, so the next step here is to connect this segment to the very beginning of your balloon. Yep. There's an answer to this puzzle. Oh no, now you're missing a segment. Well, you could pretend you did. But if that were connected, it would connect up here. And the next step is to go around the equator. Just kind of see how that's going to fill everything in. And if you, well, I don't think you have enough room. If you did have enough room, you could actually continue your end to make up for the popped one. But you could just try another instead.
It just is friction.
How we doing?
I don't know, does that look even remotely close?
That looks very remotely close.
Very remotely.
Exactly.
Like this?
Oh, hold it together. You're good. That was good so far.
That was good so
Yes, that was great so far.
Then what? I just keep going like this?
Oh, so first you want to start with the tied end so that the air can expand into this space. As you twist off the sections, it's going to squeeze air out. I would recommend the skinny balloons for the octahedron because you have to twist so many segments, but you can make whatever you want.
It fails.
Good, that's what I usually do because you can like just make extra small sections and not worry about getting everything the perfect length, which is really tough with 12 sections. It's good. And if you snuggle everything into itself, it'll be even more octahedry. Maybe. If not, you make another one. All right, where are you at? Okay, you're almost good. So connect this segment to the very beginning of your balloon.
So this one?
Yes, and then I think you can see what to do next.
Oh, sweet.
Not that she will.
Oh, such a beautiful octahedron, but it's been killed. Oh wait, you're doing so good. Don't let everything unravel.
I got this one already.
Oh, good. Okay. Great. All right, yeah. All right, this table is rocking. You've got it. And you've even got a big one just in case. It's not computationally efficient, but it does have nice color use of equators. It could be a hat.
It could be a hat. You could wear this and carry this.
Portable. We made portable octahedrons. The carry.
That's awesome.
Take that idea.
I love that idea. The portable octahedron.
And the handle doubles as a stick.
That's wonderful.
You know,
I think you ought to bring that to New Orleans with you to protect yourself.
when Maggie and I go,
Yeah.
it's gonna be what we take down Bourbon Street.
So here's kind of what I
Also,
came up with. Is that
What are you doing to New Orleans for?
it's where it is.
reason why it intrigued me was 7 is kind of an odd number.
It is an odd number, yes.
It is kind of.
And prime.
When you've got sort of binary operations, and so what it seems to me like you've got sort of like you've got sort of the 4 quadrants of rotate, where you can do a vertical and a horizontal. And since you've got 2 binary options, you'd have 4 options. And then you're acting on either something with horizontal symmetry or without horizontal symmetry. And so you'll get 8 options, but these 2 are equivalent.
Yep.
So that takes you down to 7. But then that also kind of raises the question, like, why can't you? Why is it special that you would be able to act on something with horizontal symmetry and not vertical symmetry? And the thing I'm thinking is because we're kind of going on symmetry, we're only translating in one direction, meaning we've got 2-dimensional figures, but we don't have a tessellation.
Yeah. Yeah, there's kind of, it's not like horizontal and vertical, it's more like there's a long axis and the short axis.
Yeah, we've got asymmetric axes. So instead of having...
Which 2 are equivalent? Oh, the 2 vertical.
So it would be equivalent, geometrist. This one would be equivalent to if you had this one, but you flipped it. So if you translated and flipped it, it would be the same as this one.
Let's see. Yeah, we have enough balloons. All right, so I figure we should collaborate on something big. If I can have some cessation of squeaking for a moment. Maybe a loud noise. Does someone know how to make a loud noise? Great loud noise, thank you. Okay, so I think we should collaborate on something big, and if you got something special you're working on, you can continue that. But my question is, what should we make? We could make snub units and make one of 3 snub polyhedra that might end up being either very big or very small. Or we could make some hyperbolic tilings, or we can make tetrahedra and put them into Sierpinski's tetrahedron. So what are we feeling here? Do we have any like strong opinions about whether we want polyhedra, planes, or fractals? What? A dog tiling. I have to think about that. If you think of a good dog tiling, you let me know, because I am intrigued by that idea. Anyone else have any feelings about something to make? If we were each to make units and put them together. Sierpinski? All right, we got some strong feelings about Sierpinski. That means everyone's going to learn to make tetrahedra. All right, tetrahedron. You know, the tetrahedron is a very inefficient creature. I mean, it's very small. It's only got 6 edges. It's got only 4 sides. It's like as small as you can get. And yet, you can't make it efficiently out of 1 balloon. You need 2. So, I don't know what's up with that. But basically, to make a tetrahedron, you're going to need to blow up 2 of these, the big ones. Use the fat ones, not the skinny ones. So blow them up, leave a few inches on the end, uninflated, and you're going to need 2 to make a tetrahedron. Each is going to get twisted into 3 sections, and you have to make one of those. So get to it. Beautiful thirds. You might want to collaborate together so you don't lose your thirds. Do you want to make this together? Yeah. So So basically, each of your ends is going to go to one of the middles of the other. An end will never connect to an end, or else you're being inefficient. So one of the ends will start by going to one of these middles. Yeah, you can do that. All right, there's an immediate problem with this corner that you should recognize. Each should only have 3 going to it. I like this flight swatter balloon monument.
I was not successful in creating but
Oh yeah, the fat balloon is going to be tough. You're going to need much smaller sections. I would use a skinny balloon first. Yeah.
We've had some balloon pops. We're improvising.
But you'll have an icosahedron, and that's what's truly important in life.
Well, yeah, we gotta think of what's important.
Oh, skinny balloons. That'll work. But if everything is to match, then you should use a fat balloons. But that's a good learning experience. Oh, here's a good tetrahedron. Good one. We're going to need more. Oh, you're out of balloons? Let's see if I can find more. Oh, yeah. All right, who's running out? You need more balloons? You got more balloons. I am the balloon fairy. Yeah, yeah.
That's what you're trying to do with your bottle?
Are you running out?
There you go. It's like tossing it in my hand.
You guys running out? It's a party in here. Squeezing through. What's wrong with this vertex?
wrong.
How many balloons are there? Can we get 4 tetrahedra to come together and make a larger one? Yeah, we need 4 to make a bigger tetrahedron. You could find a friend. that's a skinny one. It won't match. Actually, there is another skinny one someone was making, so maybe you can...
I did a fat one when I was supposed to do skinny, and now I did skinny one. Oh, wait a minute.
Overcompensating. Is this my pile of mess that I left here?
I don't know. It's not mine.
I think I'll grab a brownie.
First pop. I don't know either. We're making a giant.
Nice.
Yeah, that one needs to go right there.
Bonus question. What other polyhedron did you inadvertently create? Yeah. Oh, sorry. Did I hear where you're running out of balloons or skinny balloons? Oh yeah, we have more.
There you go.
There's a broken one. There's a broken one.
Let's take another look at this. Take a look. See what is up with this one. Why does this look different?
There's a vortex together.
There's a ballroom.
We need another full unit. So this one goes. That one goes. This one here and this one. Oh, okay.
Awesome. That's the hardest part.
So now if we take. Oh, that's
23.
I like your music. That was fun. Thank you. Very creative.
I have fun with it. I like your hat.
Don't you know that's the best bike helmet? I think mine's smaller.
This right.
Well, it's smaller than theirs.
It is.
I left too much here. What do I do? Oh, no.
You can join up with those guys.
I don't know if we have enough stuff to tie off to join up properly.
They'll figure it out.
Problem solving, man.
Yeah.
Got a stubby tail.
take that out.
Oh, that's cool.
We're going to migrate so we have enough room. I think we're all going to migrate.
Okay, let's migrate.